Hello everyone, my name is Mohammed Hussein and today I will be presenting you my machine learning assignment 2. This assignment is a step-by-step process to implement a multi-class classification using Iris classical dataset. The idea of this assignment is to improve what we learned in deep learning. So here we are asked to upload our iris. So I uploaded here my iris.csv, and here we're asked to upload our iris.csv into our Google Drive. So I created a folder called assignment 2, and then inside I put it iris.csv, and here we are mounting our drive. So let's minimize this one. Let's run this one and let's run this one. Okay, here we are finding the path of iris.csv file and we are saving in a variable called file name. Here we are reading the content of iris.csv file and we are saving in a variable named iris. Here we are showing the first 5 rows of the data frame. Okay, sorry, let me run this one. Okay. Here we're asked to convert the last column strings to integers. So I'm converting the last column strings to integers. Setosa is represented by 0. Versicolor, I'm converting to 1. For Geniza, I'm converting to 2. And here we are checking the first. Sorry again, I keep forgetting to run. And here we are checking the first 5 elements. Okay. Here says select the first 4 columns of the data as the data call and call it data X. So here we're in this line we're using the iloc method to select all rows and the first few columns of the iris data frame, and we are saving a variable called X, and then we are printing the first 5 rows. So let's run. Okay, now we're asked to select the last column. So here I'm selecting the last column and I'm printing the first few elements. Now it is time to split our data. So I'm importing train test split from sklearn.matter selection. And here we are splitting the data into training and testing sets. So this code will be using the train test split function from sklearn.matter selection to split the data into training and testing sets. The test size parameter, here we are using 20% random state 42 this time, and here I'm just printing the shape of the training and testing to see if it was successfully. So here I'm printing the X train shape and test shape and Y train shape and Y test shape. Here it says please split the data and label it to training and testing segments, while the size of test data is 20%, and use random size 123 to make all the answers similar into whole class. So here we are splitting the data and labels into training and testing sets. So this time here we asked to use 20% and random state 123 instead of 42. And here I'm just printing the shape of X train, Y test, X test, Y train, and Y test. So let's run the code. Please check the first 5 rows of X train. So the X train, the first 5 rows I printed here. This is Y train first rows. This is X test, and this is Y test. Here we are checking the length. Here we are checking the length of X train. I'm using the print method. I'm seeing here print for me the length of X train. Print for me the length of X test. And it says here if the numbers are 120 and 30, awesome, we're good to continue. So I have for my X train 120 and X test I have 130, and we are good to go with the assignment. Okay, number 5, it's asking us to convert Y train and Y test into categorical and call them one hot train labels and one hot test labels. So here I'm importing the NB utils from keras.utils. I'm defining here one hot train labels, and here because we've been asked to use to pass Y train, and here number class I said equal to 3, and for the hot test labels I passed Y test and num class equal to 3, and here I'm printing the first 5. I'm printing here the one hot train labels and one hot test labels. And here we are defining our sequential model that contains 3 DANs. So I said I'm importing here layers and models from Keras. So I'm defining my model here. So we have for the first layer here we have 100 hidden units with a ReLU activation function, and the second one same, we have 100 hidden units with a ReLU activation function. And finally here we are using 3 because we have 3 classes. If you remember, we have 3 classes: Setosa, Versicolor, and Fergenisa with soft activation function. So as soft max function is commonly used as the activation function for the output layer in a classification problems where we want to output a probability distribution over the possible classes. So here I I run it right? Yeah. So here we are compiling our network. For the optimizer, I'm using RMS prop, which is good just for most cases. For the loss function, I'm using categorical cross entropy, which is commonly used for multi-class classification problems. And here I'm specifying the accuracy as the metrics to monitor during the training. And here I'm feeding my model using 20 epochs with batch size 10. And here we're asked to calculate the result evaluating our X test, one hot test level, and see accurate our model works. So here I'm evaluating the model on the test data, and here I'm printing the test accuracy. Let me just run. And here we are asked to repeat all we have done in number 6. Here. Where is it? Here. So with the following parameters, the first and second layers, we are asked to use 10 Heron units with a radio activation function. And for the last layer, we need to use 3. So the reason is that we have 3 classes for that one is Satosa, Versicolor, and Fergeniza. And we are using activation softmax, and I have already explained what softmax. And here we're asked to use the same setting as we've done for 6. So here we are compiling, and I'm using the optimizer, RMS prop, and loss function categorical cross entropy, and accuracy as the metrics to monitor during the training. One more time, let me run this one, and let me run this one, and let me run this one. So number 9C says, please fit your model using epochs 4 and batch size 10. So here, where is it? Epochs, we're using here epochs 4 with batch size 10. So this code is fitting the model to the training data using 4 epochs and a batch size 10. It will train the model on the training data and their corresponding labels. One hot train labels for 4 epochs with a batch size 10. And number 9D, we're asked to calculate the result, evaluate our X test, one hot test label, and see the accuracy. So here I'm calculating the result, and I'm evaluating the X test and one hot test labels, and then I'm just printing the test accuracy to see the accuracy. And here's our test accuracy at this moment. Number 10, it is asking us, explain please all you have learned from this assignment. These are some questions that you could answer. How the number of layers or hidden units could impact the accuracy of our model. Do we always suffer from overfitting? How can we find and manage overfitting? So question 1. How the number of layers or hidden units could impact the accuracy of our model? I answered the following. The number of layers and hidden units in a neural network can impact its accuracy. Adding too few layers or hidden units can result in underfitting, whereas adding too many can lead to overfitting, both of which can decrease accuracy. Additionally, the computational efficiency, data availability, and model interpretability are also affected by the number of layers and hidden units. It is important to use an appropriate number of layers and hidden units that balance accuracy and efficiency based on the specific problem and available data by gradually increasing complexity and monitoring performance. Question 2. Do we always suffer from overfeeding? No, overfeeding is not always a problem, as underfeeding can also occur when the model is too simple and cannot capture the underlying pattern in the data. It is important to find the right balance between model complexity and the available data to prevent both overfeeding and underfeeding. Question 3. How can we find and manage overfeeding? Sorry. So how can we find and manage overfeeding? To find and manage overfeeding in machine learning models, we can use these techniques such as validation sets, regularization, early stopping, reducing model complexity, and data equalization. By implementing these methods, we can improve the generalization performance of the model and prevent it from feeding the noise in the training data. Number 10B, please try different session as we did in our number 9. You can change the number of layers hidden combine parameters. Okay. So number 10B, please try different session as we did in our 9. So yeah, okay, let me use this one. The first layer with 10 hidden units, and second one same, or let me use 64, 32, 3 liquefaction, and 3 activation, 3, and let's compile, let's see. Yep. And here we are evaluating our X test and what one hot test levels, and we are printing. Did I leave anything? And that includes my assignment 2. Thank you for watching. Bye.